Faster than light, an impossibility. Faster than light travel is a pinnacle of all science fiction. Stargate has stargates. Mass Effect has mass relays. Star Trek has warp drives. Star Wars has hyperspace. Battlestar Galactica has FTL drive. Farscape, Marvel Universe, Contact, The Expanse, and Interstellar has wormholes, and many other science fiction has some sort of faster than light travel. Now, science fiction authors aren't stupid. We all have been told going faster than light is impossible. You need infinite amount of energy to do that, and you would become pure energy in doing so. So these are all, well, at least some, although hard to do, legit ways of actually going faster than light without going faster than light, right? No. No, sadly, and no. First, I want to note that while I'm not sure if that's the proper use, I am using FTL, faster than light, in this video as a way to go faster than light without actually going faster than light. So as far as I'm concerned, FTL equals not breaking speed limit. We wouldn't want to get a ticket, right? So now that we've got that covered, let's get to why. Or perhaps let's explain these ways of going FTL. So in science fiction, a warp drive is a technology that warps space in front of your spaceship and behind it. So basically, instead of moving, you move the space beneath you. Imagine being a toy spaceship that lies on top of a fabric that is placed on top of a table. Instead of going forward, because how else would, certainly not remote controlled, a toy move, you, in some magical way, warp and bring fabric far away under your feet while moving the fabric beneath you, behind. Obviously, in this poorly executed example, we are ignoring the fact that only the fabric moves and not the table. But if you ignore the fact that tables exist in the world, you can easily correspond fabric on top of the thing we now chose not to name to the very fabric of space we occupy. So I'm not sure how warp drive solves the issue of the objects between your spaceship and your destination. Perhaps only fabric of space moves and not the thing with it. But that's not even the beginning of the problem we have here. So let's ignore that for now. Warp drive has been for some time, for me, one of the best ways to do FTL. Again, we are law-abiding citizens, not breaking any law here, because wormholes are tricky, very tricky. Now, I need not to say that I am a science fiction fan, and I've seen many examples of wormholes in sci-fi. I don't quite recall one, but what bothers me with wormholes is that time comes into question with them. Wormholes can lead to other places. That's well. Do you know how long it takes me to meet my friends in a city with 16 million other people? I could use that. But the thing with wormholes is that when you go into one, you can come out of it not only in another place, but in another time. I should also mention that stargates, portals, and all that is just a wormhole in a different attire. Okay, but perhaps wormholes where time travel isn't a case can be possible, right? Yeah, that's my hope. Oh, and I have to also mention Mass Effect, my favorite science fiction, are also a type of warp drive. In Mass Effect, there's also regular FTL that exists within spaceships, but that's slower. The FTL travel by mass relays is carried by stationary objects in space. An FTL jump occurs between two stations, and it can't happen without a relay on the destination. So in a way, it is more realistic, a similar concept to what we will soon talk about. Hyperspace in sci-fi is an alternate or a higher dimension that you move up to and then you come out of in your own space at your own destination. Kind of similar to wormholes, but slightly different. So before we get to why can't we, in any way, travel faster than light, let's talk about the realistic, scientific ways of FTL travel. So wormholes, or Einstein-Rosen bridges, are a result of theory of general relativity. Warp drive, until recently, was never based on science. But when theoretical physicist Miguel Alcubierre came up with Alcubierre drive, it became scientific. In fact, nowadays it is more plausible a way to do FTL travel than a wormhole. An Alcubierre drive works the same way a warp drive does. It warps space in front and behind a spaceship. When the space is relaxed, you are instantly at a different location of space because you just moved space beneath you. Same thing, right? So with Alcubierre drive, we have actual mathematical calculations. It is compatible with theory of general relativity. It is based on the same math. Not only that, but we have actually a way to construct it. We would need a spaceship inside a warp bubble and warp space using that warp bubble. We even have an idea about what kind of spaceship we would need in order to achieve that. The bubble and the spaceship within it will be isolated from the rest of the universe, so the effects will be limited to the warp bubble. The first problem with Alcubierre drive is we need something called a negative energy. Negative energy can only be achieved using negative mass. And the problem with those is that they don't exist. Negative mass cannot be a possibility. And negative energy is nothing like dark energy, dark matter, gravity, negative pressure, black holes, etc. You may have heard of an idea called zero energy universe, where total energy of space being exactly zero, and this is as an explanation to universe existing out of nothing. But that's not even a stretch. The energy within the universe isn't zero, and it doesn't have negative energy within it. So we cannot possibly build an Alcubierre drive with negative energy. If somehow it was possible to do it using some other way, then sure, we could attempt at it, but so far, there's not such a way. The second thing with Alcubierre drive is that Miguel Alcubierre says that to make it happen, we first need to go to the place we want to go in sublight speeds, build an Alcubierre drive highway, basically, and then, only then jump. He thinks without it, it's not possible. This is similar to how mass relays work in Mass Effect. But in Mass Effect, you already have mass relays placed across the Milky Way, so we don't need to go anywhere in boring, slow speeds. Because who likes to go at 60 at a highway? In boring real life, we don't have any mass relays, so we have to do the dirty job ourselves, instead of, well, let's not spoil Mass Effect now, shall we? And even if we did the dirty job, it may still not mean an FTL drive is possible later, because we might need to wait to warp space for as long as we want to travel. So instead of spending it on the road, you spend your time waiting for the same amount of time. Then you're there. You can't go FTL. But we haven't even come to the boss fight yet. We'll get to that. With wormholes, we have the same problem. Just like in science fiction, in real life also, wormholes could be both naturally and artificially possible. But to create and maintain a wormhole from collapsing when you enter it, you need, again, negative energy. But we know in Interstellar, black holes can be used as wormholes, and physicist Kip Thorne have worked in Interstellar, so it must be possible, right? Well, I think if we asked Mr. Thorne, he wouldn't give it a lot of chance himself. While scientifically it is a possibility that black holes can be turned into wormholes, if it is indeed possible, and if anything meaningful can come out of it, is another thing. Black holes as wormholes do rely a bit on string theory, and we know how things are with this string theory. It hints higher dimensions, which is all too speculative. There's one, I would say, more scientific interpretation or use of wormholes in science. As you may know, there's this thing called quantum entanglement. What Einstein called spooky action at a distance is two particles instantaneously communicating with each other, no matter the distance. We don't think this violates causality because you can't truly get information this way. There's an instantaneous connection, but not in a causality breaking way. And scientists like Leonard Susskind thinks that wormholes, tiny microscopic wormholes, might be the thing that connects them. It is possible that such wormholes may exist all across space, everywhere between any two or more entangled particles, and they may be what holds space together. They may be creating the actual fabric of space. But even if such wormholes are real, They cannot be used in a way to be taken advantage of. In another video, I may go into more details about this. Same thing applies with a hyperspace. We don't have any evidence of a higher dimension. The only good argument for a higher dimension is that it explains gravity. String theory explains gravity as a force that leaks from another dimension, and that is why it is so weak. But good doesn't mean real. There may be a million other explanations to gravity, or it just might be weird. So let's get to the final boss. With all proposed ways, wormholes, hyperspace, warp drive, FTL, faster than light is an impossibility because a little thing that keeps all universe going, a little thing we call causality exists. You understand what I'm saying right this moment because causality exists. Your mind works because causality exists. Things cause other things to happen. And things happen in one direction. Your thoughts don't form because you said some words out of thin air. You form thoughts, then speak those thoughts as words. Any FTL travel, no matter if you break the speed limit or not, breaks causality. Any FTL travel would break the inseparable relation between space and time. Space and time isn't two separate entities. It is space-time, and space is tied together with time. Any distant object cannot transfer information any faster than light because it is tied to us with the speed of light. Without speed of light, anything would happen instantly, and that would mean nothing would happen. Things happen because it takes time for those things to happen. If light didn't have a speed, it wouldn't take time for it to travel, and we wouldn't be able to see anything. We wouldn't have processes happening within our minds if it didn't take time for them to happen. If you were able to travel faster than light, and if you traveled to a place where someone was looking to at the time you traveled, they would see you there. But then, for them to see you there, the images being sent with light to them would have to come from the past because it takes time for those lights to come. So traveling to a place where someone is looking at would mean traveling as far into the past as you traveled as far in space. You cannot separate time from space. Any FTL travel that can bypass the speed of light in any way can be used as a time machine. As a time machine for traveling into past. Time travel into future is not a problem, but traveling into past can only logically be acceptable in a many worlds of quantum mechanics way. MWI is a real possibility. It is currently one of the best interpretations of quantum mechanics. But traveling to a parallel universe just to go somewhere I would risk and bet is something no one wants. I also have to mention gravity bends space. Black holes do it in the most absurd way, and dark energy expands space. So why can't we do it? We know that gravity isn't very useful for this type of travel. It can be used as a slingshot effect, and it can be used to travel into the future, despite how sci-fi that sounds. But it can't be used in a way similar to these examples. Black holes could be wormholes, but I would again bet that they're not. So we know from gravity that space bends, but does that mean it can be used in an FTL travel? Would you fall within an event horizon of a black hole at a rate faster than light if a black hole was a billion galaxy mass? Would it pull space itself at an FTL rate? Now I'm not sure about that, but what I know is, if the universe had a density greater than the dark energy, as it did in the past, the universe would first slow down, then collapse in on itself. That could make things go faster than light without actually going faster than light. The same thing kind of happens right now as well. For every place within the universe, there's a cosmological horizon. Our cosmological horizon is the limits of our observable universe. But there's more universe beyond what's observable. Beyond that is the places where the universe moves away from us faster than the light. But have you noticed something with this? Not only this effect is the opposite of traveling towards something, but also the moment you travel faster than light compared to another location is the moment you are causally disconnected from that location. And even if you weren't causally disconnected, you still wouldn't see anything weird because FTL travel doesn't happen between the locations that matter. So even though dark energy allows for FTL travel in relation to another place in the universe, it is the opposite of a useful causality-breaking FTL travel. So we get back to the big crunch then. If such a future were to happen and we were soon to be crunched, will we be able to travel FTL if it was the last thing we did? I would say not likely. I think depending on the density, we would not be crunched at an FTL rate. And if it did, we would probably be turned into energy. Even if it didn't, we would be crushed before crunched, so we would turn into energy anyway. Perhaps we would FTL travel for real this time. Who knows? What is more useful for FTL travel is not to FTL travel, I would say. Let me explain. The only useful and realistic way to travel without dying waiting on the road asking are we there yet every decade is to travel at relativistic speed, and there's not even a limit to how close to the speed of light you can go. In practice, you can go as fast as you have energy for without actually going at the exact speed of light and go anywhere. You can choose how long will the road take. Say, if you traveled at a 1 to 299,000 something rate, you can reach Andromeda Galaxy even within an hour. That's much faster than the speed of light. Or is it? Now, speed of light is a bit tricky thing. For light or any other particle that is massless that travels at the speed of light, there's not a sense of time. For light, traveling from the edge of the observable universe to here is instantaneous. For light, no time has passed since the beginning of the universe. But for us outside observers, that takes billions of years. The same light also instantaneously comes here from Andromeda, but we see it taking 2.5 million years. The same thing applies to our travel. We would indeed travel to Andromeda within an hour, but people here on Earth and whoever is on Andromeda would see it take 2.5 million years. As long as you have nothing to leave behind, you can travel anywhere as long as you have energy. The only thing to be careful about is your acceleration. You would want to spend at least 1 year accelerating to near speed of light and at least 1 year to spend decelerating from speed of light. At least that is the limits of human bodies. So any travel would take 2 years or more, but that might take a lot of energy. Like a lot. We might need to make do with a few hundred years, but as long as you have energy, that's the way to do it. Any other way remains to be a sci-fi. But one could still hope to be proven wrong.